Let's try that again. Yeah, so we have sound at least. Good start. Hi, Iron Tux. Welcome. I'm just setting up the last things here. Trying to get some music on the stream, but yeah, that seems to not be happening at the moment. Oh, actually, here we go. Awesome. Guden, hello. Guden, how do you pronounce it? All right, let's get started. So, we had a great release actually yesterday. I managed to, or was it the day before yesterday? I managed to finish up the Tesla module. Finish up is maybe kind of an overstatement, but at least it's working, and I released version 1. And I've had some great feedback so far. I've been in contact with a few people who actually used it, which is really cool. This wallpaper is psychedelic. Yeah, it's my starting soon screen. I wanted something, yeah, something nice that could resemble space or something. So I found this free little video that I put on a loop. Right, so today we have our PowerShell module. It's working. I did implement most of the things in the app, and we can now just do all the things we can do in the app. So I thought I would try to do something that I haven't done in like maybe 2 years. I'll actually start building a durable Azure function. So I just created a new folder. I called it Tesla service, and it's totally empty. We're doing this from scratch, and I have no idea where to, or I don't really know where to start or how to do this. So bear with me, but I think we're gonna have a fun stream. I hope at least. And I hope you all have a good time and that we can have some nice interactions. It's so fun when you write stuff in the chat and we have some kind of interaction. So let's get started. What's the durable fun? That is an amazing, great question. I should probably explain that. So in Azure, there is something called Azure Functions, and it's a way of like building a simple API. You can write them in a lot of languages. I usually use PowerShell, but you can use like Python or Node or C Sharp or JavaScript or whatever. There's a lot of languages supported. And when you create a function, it's basically like an Amazon Lambda service. So you create an API and you can call it API using HTTP, or you can create small pieces of code called functions that can execute when they get a message on a service queue, or they can trigger on like when something is uploaded to storage, or some other kind of event. Really great service, awesome. We use it a lot. Durable functions. So the problem with functions is that they're basically stateless. So you trigger a small piece of code, it runs, that's it, it's done. And if you do regular functions and you do like the serverless version of them, they have a runtime limit of, it's either 5 or 10 minutes, I'm not sure. So you can't really run something for a long time, and they are not very good at doing like monitoring tasks or orchestration tasks. You also pay per second that they execute. So if you don't run it, they're free, and every second you use it, it'll cost you a fraction of a cent or something. Durable functions, on the other hand, is like an extension of functions where you can write orchestration like logic, so you can have long running functions, and that's basically a workflow that starts up, does something, and then goes back to sleep again, and starts up and does the next thing, and so on. And for every call it does to something else, it will save its state. So basically it saves the return value from that it got in the previous step into a storage count. So we can a durable function can do a lot of things. We can do like parallelism, and we can do long running functions and stuff. And today we're going to do an orchestration function. So I'm going to try to write a workflow that can that I can trigger, and when it triggers, it will connect to my car, it will wake it up, and then it will do a bunch of things. And today I'm gonna focus on the climate settings and making the car ready for takeoff. Yeah, so we'll start that, and we'll see start with that, and we'll see what happens. And to do that, I have a CLI called Func. It's the Azure Functions CLI, and I hope I have it installed. So I can do like this. It's there. So I can this is CLI, and I can use the CLI to also, I need to make a Git repository of this. So let's start by doing git init. So we have a Git repository, and then we can do the rest from Visual Studio Code, I think. So let's open up this folder in Visual Studio Code. Let's bring it onto the right screen, like over here. As you can see, it's a totally empty directory, and I think I have a functions. Yeah, I have a function extension, which means that I can do create new project. And I'll say it will be this, and it will be PowerShell. Durable functions with an HTTP starter. Yeah. So a starter is something that like starts the whole durable function thingy. Repair takeoff. It should be a function authorization. So each time we create a function, we can choose an authorization level, because every function app, like the actual service, will have function keys. We have one admin key, which will be a key that works for all the functions and for the admin API. And then we have a key that for each separate function. So I can choose if this function should have its own key, or if you need access with the admin key. Thought I forgot my soda. All right. So that is going ahead and creating some connecting to the gallery. Wonder what it's doing. We'll see. So this created some basic files for us, and I hope it will create the rest soon. We get a proxies file. This is to configure proxies that we can do, so we can basically proxy incoming commands to another API somewhere, like a very lightweight API manager. We're not going to use that here. Then we have this profile script. This will run every time my function service starts up. So this is basically like a startup script that runs every time it starts. In there, I'm going to write some. Yeah, I think I'm gonna write some logic on how to connect to the car, like just load an API key and stuff. And that reminds me that I'm not sure I've actually implemented that part in the new authentication method, but we'll see. Now it seems to be complete. So we have the profile, we have a local settings.json. This is a file where I can just put my settings for when I run the debugging locally. I have a host.json. This is the configuration of my host, like my service. First thing I want to do is to disable this. Manage dependency is not allowed. Funky. I don't know what it is, but I don't want it anyway, so I'm going to take it away. There is also a requirements file, which is the input for the managed dependencies. So if I have this managed dependencies enabled, every time my app is deployed, it will go to the PowerShell gallery and download all the modules that I need. I'm not a fan of this because that means that I have a reliability on the PowerShell gallery to be available, which I've found is not always the case for obvious reasons. There is not really a service level agreement on the PowerShell gallery. They don't have an SLA. They don't guarantee the service to be available, and it's not built for high availability. So sometimes it's slow, sometimes it's not working at all. Usually it's working, but I don't want my services to be depending on the gallery to be online. So I always download my modules and deploy them together with my code. So I'm just going to remove this whole file because I don't want it. Also the proxies file, I'm going to remove that because we're not going to use that. So let's clean it up a bit. I removed the managed dependency part from this host configuration file. And we have a git ignore, that's totally fine. We have a func ignore, also fine. This configures which files we shouldn't deploy to the function when we do a deployment with func CLI. Then we have a folder called prepare for takeoff. So every function we create will have its own folder. In that folder there will be two files, a function.json, which will be the configuration for this function. It says it has the authentication level of function, it has a name, it has a type, so it's a HTTP triggered function. Sorry, this has a binding. So the first binding is a HTTP trigger binding called request, and it routes to this, and yeah, so on. It also has an output binding, which is HTTP, which is required to get an HTTP response to the caller, and then we have a starter binding, which is the orchestration client used for durable functions. So these are the bindings. And run.ps1 is the code for the function. So when we start up, it will get some basic example. In this case, we will get a function name from the parameters that was specified in the request. Think params is query strings, and then it will just start that function. And then it writes an output saying it started with an instance ID, and then we create an orchestration check status response. So this basically builds an HTTP response object, and then we do push output binding and give it that response object, which will give us an HTTP 200 back with a bunch of links in the body saying this is an address where you can call to check the status of your workflow, and this is a cancel workflow, and so on and so on. So this is pretty standard, and I'm actually not going to do anything about it. Maybe, yeah, let's leave it like that at the moment. And then we'd say function. I wonder what that's called. Maybe create function. Create function. Yes. So now we need an orchestrator. This is the script that will run over and over and over and over and over again until we are done. Let's call this prepare takeoff or I'm actually going to rename this one. So we call this start prepare takeoff. We need to, I think there is, no, nothing more. Cool. I think we'll be alright. And we'll try to create a new function again. We'll choose the orchestrator and we'll call it prepare takeoff. Good, that worked. So now we created prepare takeoff, and that gives us an input that is the context that we get from our trigger or starter. And this is just an example script. That will be fine for now. And here we can see that we have only one binding. It's an orchestration trigger, it's an inbound trigger, and it's called context. So that's all fine. I'm gonna change my mind again. I'm gonna call this prepare takeoff client. Maybe. I don't know. We'll see. I probably changed my mind a few times more. So let me think. On top of this, we need a modules directory. Not there, it should be here. Modules. So there is this magic feature that means that if you create a modules folder, the modules in here will be added to the PS module path, which means that it will automatically be found by your service or the function runtime. So let's do save module and give it a name of my Tesla and say add. So this will download the My Tesla module from the PowerShell gallery, and it will save it in the modules directory, where we need it. Oh, sorry, I think I was talking while I muted my microphone. Thank you very much. I was, yeah, I'm back. Sorry. Hi, CTI Geek and Bjompen and Stefan and all of you. Sorry, I lost track of the chat while I tried to concentrate. So what I was saying while I was on mute was that there's a module that's there are a few modules that's embedded into the functions runtime, and these modules are available inside our functions. So whenever we load a function, these modules are the ones that we can use. Although that didn't work because that has dependencies on other stuff. So actually I'm going to do this. We have this environment variable called PS module path. This contains lots of things. So this is like the path module, but for PowerShell modules. So whenever we try to run a command and PowerShell don't have that command loaded, it'll look for modules in this in these folders. So I'll just do it like this and say this one should be equal this modules folder and the current environment beans module path. So we'll just take both of those and we'll do a join and say environment path separator. There is like a no, it's a system IO. I think maybe. What's the there is a whatever, let's just do this. So now this should start with my function core tools thingy. I was looking for a static property that contains the semicolon for Windows and a colon for Linux. It's called like a path separator. Let me Google that real quick because I'm curious. So, error, yeah. No, I don't want Chrome. Like PowerShell path separator. System IO path. Yes, that's probably the one. Let's do system.io. Yeah, maybe. That wasn't the one I was looking for. Ooh, there's a lot of them. There's separator invalid path separator. That's the one I was looking for. Yay! Very long time to find a semicolon. Anyway, I try to, whenever I do stuff, I try to think about doing it cross-platform. Colon color to separate the char your chat show thingy hides brackets. It seems yes. Yeah, it seems like we can't write funky characters in chat. We'll have to work around that. Yeah, every time I try to do something, I try to think cross-platform to get used to that and to learn basically. Now we should be able to do the import module. Where were we? There we are. No module was found in any module directory. So let's do it the hard way then. There's supposed to be a DLL here somewhere. This one. And I'm just gonna do this, my awesome search tool. If you haven't tried void tools and everything, please do. This is like the best thing. You can type whatever you want here, and you can use regular expressions, and it will search your hard drive this fast. Amazing. You can just copy path here, full name to path to clipboard, and then we do import module path. IPMO. I always misspell that one. And we have a module. Awesome. And then we should be able to import that one. Still didn't work. No valid, but it's right there. That's, oops. Not sure what I just did. Let's just take this thingy and take this here. Whatever. Let's try the PSM one then. Okay, that worked. Yep, so now we have two functions modules installed. And we can do like git command dash module Microsoft dot Azure dot F star, I think. Ooh, finally some progress. So these are the functions that are available to us. I think I managed to load them twice, but whatever. So we can wait for stuff, we can get some, so this is probably some private that we shouldn't be using, and this one should work. Yeah, alright, that'll be a good start. And then we go back to our use code, which is here. And now we have the module downloaded. That's good. So we take that, we have the prepare takeoff, we have the client. So this client basically calls this prepare takeoff orchestrator, and the orchestrator should do something cool. So first off, we should so we assume we're already connected. Let's see, let's do that in the profile. Don't think we need this. We should definitely not do this. Let's just comment this out, and yeah, let's just add some code on here. So we should do import module dash name my Tesla, because we need that imported, and we do that at startup. And I'm going to do error action stop. I'm quite sure it will stop anyway, but just to make sure. And then we need to connect. So I think import module my Tesla is connect Tesla syntax. So this will show the syntax of the command, and I can run it either with a credential, with a refresh token, or an access token. I'm going to run it with an access token at the moment, I think. Or at least I will that eventually. So we're going to do this thingy. So access token equals dollar environment access token. So I'm going to store this in an environment variable in our function app. We will have app settings where we can securely store secrets, and those will be injected to our environment as environment variables. And I will convert to secure string, I think it is, dash as plain text force. And then we'll do this. We should probably import the vehicle ID and this like this. And then we'll do select Tesla vehicle dash ID vehicle ID. So this should work, and I'll just do import Tesla context here, because that will import my cached settings. So I should be able to do get Tesla vehicle, and that should load all my cars, which is the amount of one, and that's the ID. I wonder, maybe I should do like environment, the environment variable, and do Tesla vehicle ID. Now it's my memory again. I don't remember in which order these come anymore. So if we run this without any parentheses, we will get the signature of the method, which tells us how we can run it. So we do it again, and we say the first thing is the name of the variable, the second thing is the value. So that should be the value I had up here. This one. And the third one is an environment variable target. So we're just gonna do this, and there should be a user here. There we go. So now we have an environment variable like this. Oh yeah, and we need to load it here too, because it's not, it only applies to new processes. There we go. Let's just make sure I spelled that correctly. I did. Cool. So this should be working, and we should select the vehicle. So every time we start up, we will connect, or like actually load the access token. So this connect command will not actually do anything. If you give it an access token, it will just store the access token in memory, so it's like available. And then we will select the vehicle, so we have a vehicle selected, and that should be everything. Then we go to the prepare takeoff, and we want to do something. We want to start by waking up the vehicle maybe, or getting the vehicle. So I think if I remember, there's a get Tesla vehicle configuration data state. That didn't work. wonder if I broke something in my profile. Let's try that one and run that one just to make sure that this one works. And then we try it again. That seems to be working. So this is waking up my car. That's why it's taking a while. And once it gets connected to my car, it should return a vehicle state, hopefully. Hey, what? Cool. Welcome. Nice seeing you again. So this gets us the states. See, I'm not sure. Yeah, so this is like all the windows. The user is present. If it's locked. Oh, I think I got a new version available. I thought I just installed that one. Yeah, I did. Oh well. Yeah, that's not what we need. We need the vehicle data, maybe. Let's try that instead. Here we go. That's the whole thingy, yeah. I don't have a color. Interesting. It's online. Charged it. This is what we need. So I'm not sure if we should get this whole thing or if we should just get the climate state and get. I think I have a Tesla climate state. Yep. This we're gonna use this a lot, and then we should have like get Tesla. Charge state, climate state, drive states. Let's just look through this, what they contain, and see what we can find. So this is my location. What was the other state? Drive state, charge state. There's a lot of information in here. Apparently I got a 2-volt charger. Ideal battery range charging. So this is probably something that we want to take into consideration. And so what are we working on? We are building a durable function. A durable function is a Azure service that can execute code for us. So I'm going to do a prepare for takeoff service for my Tesla, which can prepare the car for takeoff, basically. So this is my orchestrator. I don't want to do anything in here, so I'm just gonna do like initial mm, state of charge equals, and then we need to call one of these other functions, which I had in this somewhere here. So I think I can like wait activity function new sense start. Invoke activity function, that's the one I'm looking for. Function name input, no wait, retry options. Perfect. Let's try that. So we want to invoke activity function. Do this because my memory is function name. And say get charge state. And then we could supply it with an object. I don't think we need that. So we need a new function, create function, and it should be in durable activity function. And we're gonna call it get charge state. Here we go. And we have a parameter which we don't need, so I think we can remove that maybe. And we should just do get this charge state. So this should call the car, get state, and return it. So the thing with this, it seems kind of weird, but this will actually, so when this is run, it will save whatever result we get here into a storage account and persist that. So next time we start up the orchestrator, it will know that, oh, I already ran this command and I got an answer. So I'm just gonna read the answer back. I also think there is a way to get dates somehow, but I'm uncertain. Let's skip that one for now. So if initial state of charge dot some fun battery level. Let's just do this. Is greater than something. I don't know. Would the data have been changed? Yeah, so the thing with the orchestrator function is that it will run until it finds a pause or sleep or something to wait for, and as soon as it waits for something, it will go to sleep, and then it will start up again and execute from the beginning, but it won't repeat the steps it has already done. It will, because it will have changed saved that data. So no, the data in the variable will not be updated. It will be the same like it was when we initially called it. So if it's greater than 25%, because I probably don't want to do any massive climate changes. So actually, if it's lesser than, we could probably just return vehicle charge state is too low. That should do it, I hope. And then we need to get the climate. We just do the whole thing, and then we do this one, and we call it get climate. state. And we need a new function. It's an activity, get climate state. Don't need any input, and we'll just do get Tesla climate state. That should do it, I hope. While I'm thinking about it, we should probably make sure. Yeah, so if I run this with an invalid vehicle ID, it will error out anyway, so that should be fine. We don't need to validate that. This will just get the climate state, and we'll get the climate, and then we'll have some like comfort levels. I think we'll just hard code them up here in for simplicity. So $defrost threshold maybe equals, I don't know, 0 or 1. Let's do 1. And we have like comfort. This should probably be configurable later on, but we'll start with this. Comfort temperature there equals, what's comfy? Let's say 25 degrees. 22 degrees. I'm not gonna translate to Fahrenheit. If anyone prefers that, you have to do that yourself, because I'm really bad at Celsius to Fahrenheit transformations. So let's do a max cooling threshold, and that should probably be like, I don't know, 30 degrees. So my plan here is to get the state of charge. If the battery is lower than 25%, we'll just exit. Then we'll get the climate. So that will give us. Sorry, Waz, it wasn't intended at you. Then we get the vehicle climate. So that should give us back some temperature. And just to make sure, we do get Tesla climate state. And here we get some climate state, and there should be like a inside temperature. This is what we're interested in. And there's an outside temperature. So currently we have 11.2 degrees in the car and 9 degrees outside of the car. So if the outside temp is lower than like 0, which is the freezing point, or maybe like +1 to get some if dollar vehicle climate dot outside temperature is lower than 1. So it's, if it's 0 or lower, it's potentially freezing, and that means there might be ice on my windows. I don't want ice on my windows when I drive my car, so we need to heat up the car. And that should invoke the activity function called start defrost. Maybe. Let's quote this so we get some nice brownish color. Else if the inside temperature of the car is lesser than, actually greater than the max cooling threshold, then we should invoke start max cooling. Right? So if it's really cold, we'll start the defrost. If it's really warm, we'll start the max cooling and we'll get the car down to a good temperature fairly quick, but we will use a lot of energy. Then we'll probably just chill out for a while. I think there is like a weight, durable wait, sleep. Wait durable, stop durable timer task, start durable timer. Wonder what this does. Start durable timer, duration, time span from seconds. 5. Go. Didn't work. Awesome. Okay. So yeah. In the future, if I start a defrost or I start a max cooling event, I will probably want to wait for like a few minutes before I do anything else because it'll take a while. Let's see what says. We should get the inside temperature for the inside one. I mean the max cooling one. You are absolutely correct. Thank you. Inside temperature. Awesome. Let's do this and say standard sleep interval seconds 60, and then we'll do like and the sleep intervals times 5 or whatever. So that should be 5 minutes. And then we can, when we are debugging this, we can just do 1 and it will go really fast. Alright, so this should... defrost active. Max heating active. Let's do this and let's have these return true or false. Could get cold sooner. Yeah, sure, it could, but so I'm thinking if I start the max cooler, like if there is 30 degrees or more in the car, which is not that hot, but quite hot, and I do like the max cooling for like 1 minute, and then I stop the cooling, like the seats and everything inside the car will be so hot, so it will like warm up the car instantly again. So yeah, and the same is for heating. Like if it's 0 degrees or colder outside, and I heat the car up to like, yeah, for 2-3 minutes, it will probably be like 20-25, some fairly comfortable inside temperature. But I want all the ice on the windows to melt, so I probably want it to run for like at least 2-3 minutes, but probably at least 5 minutes. But yeah, we'll see. But you're right, maybe like if it's only 0 degrees, maybe it's enough to heat it for 3 minutes. But it's like if it's -20, which is sometimes, and -10 is not that unusual, then it'll probably need like 7, 8, 10 minutes of defrosting. So, but 5 minutes defrosting is like, yeah, I think we'll be fine there. And after 5 minutes defrosting, if it's too warm when I get into the car, yeah, I'll just open the window for 10 seconds. But we'll make this configurable somehow, and we'll start with 5 and see what happens. So now the car is probably fairly warm or fairly cold, depending on if it's summer or winter. And now we want to do some kind of lube. So I wonder if this thingy returns something. Is there a help for it? No help. Let's do a quick Google. Amazing. My friend and colleague Emmanuel always has the best blog posts. Start durable timer. It's lacking documentation. Awesome. All right. That didn't help us much. Someone else? Cost of sleeping. It's really old. Probably don't need that. Or we can just try it out. It would be nice to have just some. No. Okay. Enough googling for today. Let's just wing it. Hello, Emmanuel. Yeah, I just read your blog post, and I guess I owe you a beer for that. Thank you very much. And welcome. Mr. Epix is the author of the blog we just read. Where were we? Yeah, durable timer. So, Emmanuel, Mr. Epics, do you know if the durable time, if we can do a durable timer no wait and get the timer object back and kind of test it for time, or yeah, so I'm not sure what. Yeah, I want to start the timer when I initiate the workflow, and then I want to keep track, like if it's I have an orchestrator pattern where I'm going to change the climate, but I want like a time limit of 20 minutes. So whenever 20 minutes has passed from initial start, I would just want to gracefully exit. Anyway, we should do like while something, I guess. We should put something better in there. Wonder if we can do this. So I want to update this. I'm not sure if this will work, but I want to get the vehicle climate, like an updated version of the vehicle climate all the time for every iteration. And then oh, awesome. Our examples. Look at those. Oh, you've done a lot of... Yeah, so this just pauses the whole thing for one day and then runs again. While tomorrow, less than expiry date. Expiry date is an input and tomorrow is... Ah, awesome. That was the one. So this is not something you supply, it gets supplied to you. Something save state between timer runs though. Alright. Cool. Let's do that. So like start time equals that. Hopefully that is saved between runs. We'll see. And then you probably do like while come think of it, I want to do something while dollar while not or until actually until driver present or current UTC date time. So we need a UTC date time. That's a daytime offset, right? Daytime offset. Now it's not a method, it's a property. UTC datetime. This is the UTC datetime. So UTC datetime. Cool. Time passed is greater than timeout. So I think if I do this stuff like add minutes -1, so I can take I can take one UTC datetime, and I can subtract another datetime, and that should give me a time span back. And that says minutes. Cool. So if time passed dot minutes is greater than timeout, we should also exit. Yeah, that'd be fine. So down here we need to calculate we need to start by get vehicle climate. I hope this will run anew every time, but we'll see. And then we'll do driver presence, and I wonder how we got that. Didn't we have like a get Tesla climate state? I think this has a driver presence. Oh, car is sleeping again. Lisa, hello, welcome. Oh, come on, wake up. There we go. Oh yeah, I look really frozen in the stream. You are absolutely correct. Technology is not on my side today. Let's see if we can do something about that. My video is still built. I hope it hasn't been that for a very long time, but no, no one has told me. Let's see if we can just... I'm gonna switch off my camera real quick and see if that works. I'm still really frozen. Dang it. Is there a way I can... Oh well. Things happen. I think there should be like a way to deactivate this thingy. Not really. That didn't work. Let's see if we... Yeah, it's live. So you'll see my whole room without a green screen. And we'll see if we can deactivate the source. And activate the source. Aha! Here we go. That's better. And we'll go back to our Twitch view. I'm moving! Thank you, Isa. I'm back. Let's see if we can find some... so there's no presence in here, so we need to get the Tesla some other state. Vehicle state. Is user present? This is the one we're looking for. So vehicle state equals, and we'll do this whole thing here, and we'll call it get vehicle state. Regarding the code, I think you may want to use context.current UTC date. Oh. Maybe US experiment in the console because I can see it. Yeah, so this is the thing, and I haven't calculated the time passed yet. So I'm hoping this will be persisted, and then I can compare that with current UTC's date time later on, and we'll see what happens. So we will get the vehicle state and we will get the vehicle climate state. And driver presence is equal to vehicle state dot whatever that was called is user present. Let's call it user present. So if that is true, we don't want to do anything because as soon as there is someone in the car, we trust them to be able to fix the temperature the way they want. And then what we want to do here, we want to check the temperature and set it to a comfort temperature. So if if vehicle climate dot inside temp is so if I'm warming, I want it to be more than the comfort temperature. If I'm cooling, I want it to be way less. Maybe I should just do like a target temperature. Sure, is equal to target temperature if is equal to, so if I'm warming it should be +5, and if I'm cooling it should be -5, right? -5, that's 17 degrees. That's fairly cold. I probably want it like -3. And if I don't do any of these, I'll just set comfort thingy something like this. And just say comfort heating start comfort climate, maybe we should call it climate. It's the goal to check every X interval to see if the temperature is good, otherwise adjust it up or down depending. No. So the goal is to, if it's really cold outside, do a lot of heating. If there is a lot, if it's really warm outside, do a lot of cooling. If it is something else, just say like, set the temperature to 22 degrees or the comfort temperature, and leave it at that. And whenever we have been running for more than, let's say, 20 minutes, we should just turn everything off. But I want to... So whenever I start the max... the defrost here, the max warming, I'm just gonna wait for a certain time here. But... So this durable function is your entire takeoff orchestration. Yes, this durable function is my entire takeoff orchestration. And then I have these actions that do stuff, like talk to the API. That's the plan, at least. Whoops. That's supposed to be curly braces. It might be a good idea to chain them in some way, but yeah, let's try this. So whenever we get down to this part, either we have been heating for a long time, or we've been cooling for a long time, or we just started a comfort climate. And this should probably take an input. I think this accepts an input. Let's go here and say like this, and syntax. So yeah, it takes an input. Awesome. Right now it's only going to have been heating cooling for timer ×1, since those timers are not in a while loop, but maybe that's what we want. Yeah, so if we start, if we enter this, then it's really cold outside and we want to start the defrost and wait for 5 intervals. And for the debug part, an interval is 1 second, but in the future it's probably 1 minute, because we always want to like run the defrost for at least 5 minutes. And then if it's really warm outside, we will start the max cooling, and that will run for at least 5 intervals. And if it's not really cool or really warm, we will just start the comfort on high. So we'll just set the regular AC on like high, whatever that is. We'll get to that later. And so this is just like the startup logic. Where are we? Which scenario are we running? Then we want to do loop. That's the thing down here. And this loop should be like get the vehicle state, get the climate state, and check if anyone is in the car. If we are in the car, just exit down here. We will exit the loop if we have user present. And then if the vehicle inside temperature is yeah, so if the inside temperature, current inside temperature, minus the comfort climate. So let's say it's 20 degrees in the inside temperature, and we subtract the comfort temperature, which is 22 at the moment. That'll give us an answer of -2. So if that is greater than our target temperature difference, then we'll set the comfort climate to regular. Right? So this means if we are 5 degrees above our comfort temperature when we are heating, or if we are 3 degrees below our comfort temperature when we are cooling, because we always want to go like past our target a little bit, because when we turn down the max cooling, the seats and stuff are still a bit warm, so the temperature will rise again. And if we are enough past that threshold, then we will set this back to like automatic or auto or whatever. And this should probably set this to 0 down here. So this will just like start it with high fan and stuff. It will not start like the heat seating, and it will not start the like windshield defroster, and it will not start the back rear window defrost thingy, and it will not start any of the like max cooling or max warming features. Just like put the climate control on and put it on high, and then if we reached our target temperature difference, that means that the temperature inside the car is all right, and we will do a start comfort climate in auto mode. That will just say like do automatic comfort thingy. Actually, we should probably give this a hash table and say temperature equals comfort temperature and mode. And I think we have a command list, but let's try that. Set Tesla something, seat temperature. Perfect. So high, low is max heating, max warming. Temperature is just 20, and that should, if I remember correctly, just start the fans at 20 degrees. Come on, wake up. Yes. So that just sets it to 20 degrees. It doesn't start anything. Then we have start Tesla climate. That just turns the climate on. Yes, I probably don't have a in the app. Yeah, I can't do any heating or cooling in the app either. I can just turn on or off defrosting and set to... Yeah, alright. So we can do set temperature to comfort temperature and mode equals high. Yeah. Let's just set it to comfort temperature. All right. That will do for now. And then if we go down here, we will do like this instead. Yeah. So if we're inside this loop, we're happy, and we should just do like the set comfort climate thingy. So we can do this, I guess. And then we just let it run. And then we need to calculate the time passed. So time passed equals context dot current UTC time. Whoops. Minus the start time. I hope that is how it works. And then we need to set the timeout minutes here. Already first threshold. All right. I think that should work. So this should start heating and just keep the car warm until I get to the car, and whenever I enter the car, it will just stop doing stuff and trust that I can control the heat myself. And if I haven't entered the car after 20 minutes from starting this, it should just shut down, because I don't want to run anything more than 20 minutes. If I'm not in the car after 20 minutes, I'll just assume that I changed my mind and I'm not going anywhere. Because that has happened, and I have, so I can explain why I do all this. Let's see if I can get my phone up on the screen. This seems to be kind of simple and rudimentary, but it's actually a little bit pain. Hopefully start time retains its original value. Also think that's how it works, but it has been a while. Yeah, I'm that's an assumption right now. We'll see what happens. We'll have to do some debugging on this. I'll start my phone. Come on. Connect the phone, please. There we go. So this is my phone, and this is my app. And whenever I'm about to go somewhere in a car, I have to start the app. That takes a little while. I can show you now, but let's say it takes like 5 seconds for the app to start up. And then it says like waiting for a car to wake up or something. Waking up the car takes between 30 seconds and 3 minutes if I'm unlucky. So I have to take up my phone, I have to open the app, and then I have to wait for like half a minute to 3 minutes, and then I have to go into climate, and then I have to, now we have a button here, that's good. Before we didn't have that. So then I have to press this, it turns on the heating everywhere, and then I have to turn on the seat heater if that wasn't turned on. And if it's warm in the car, I have to go in here and I have to click this a lot of times, until it says low, and then it says max cooling, and then I have to control the seat heater. So that takes like, it's not a lot, but it's still like a lot of fiddling. And now when I'm doing like the max cooling or the max warming, I also don't want the heat thingy to be on, but I think it's, yeah. This takes a fair amount of energy. So I don't want to run this like in max cooling or max warming, especially not max warming, for more than like 5, 6, 7, 8 minutes something. Because if I forget this for like half an hour, it's gonna drain like 20% of my battery. I think it's a 6 kilowatt heater. And on top of that, if the battery is cold, it's gonna use the engine to heat the battery with another 3.5 kilowatts. So I'm consuming, like if I do max heating, I think I'm consuming 9.5 kilowatts. So the car consumes like 2 kilowatts per 10 kilometers or something. 2 kilowatt hours per 10 kilometer. So if I run that, the whole thingy for an hour, that's like driving 40 kilometers. Is my math right? I don't know. It's a lot of energy anyway. And since I don't have the car connected to, you can see it has cooled down from like 21 to 13 just during this time. So whenever whenever I'm happy or it's a good temperature, I just want to set it to the comfort thingy. So yeah, so that's why I'm doing this. And in the end, I want to build an IoT button. So I want to have a button inside of my in my hallway, just inside the door. And then whenever it's time to go somewhere, I'm just gonna press the button and start this whole workflow, and not have to think about it. It's gonna connect my car. It's gonna wait for it to wake up. It's gonna set all the settings depending on whatever. You also have, yes, I have API control for the seat heating, and I will put that into the action thingies. Is the plan. Yeah, so I just want to leave it and don't not care about it. And if we realize that we're not going anywhere, it can just turn off the climate after 20 minutes, because it has happened that I turned it on like max heating because I think I'm going somewhere, and then I didn't go somewhere, and like an hour and a half later I get the notification from app saying your car battery is drained and I'm turning off the heater now because you only have 20% battery left. And yeah, then I have to go charge the car because I can't charge at home. A lot of wasted time and energy and money. Well, not as much money to be honest, because it's fairly cheap to charge, but time, energy, and environments. So if I get down here, I'll say if $user present, if not user present, actually. Not as cheap as my new function. No, my new functions is actually going to be free because I get like 3 million invocations a month for free or something. And I'm not gonna do this 3 million times a month. So yeah, it's gonna be free. We should just do like some invoke thingy, stop everything, whatever. Stop climate. All right, so that is the goal. We need to implement all these action thingies. This isn't used, so I know. Let's keep it. Yeah, I think that's a good plan. And time is 1 hour and something, like almost 2 hours into the stream. I'm getting a bit tired. It's almost 11 p.m. here. So I'll actually say thank you very much for hanging out with me tonight, and hopefully we'll do a short stream some night later in the week, like maybe Thursday or maybe Saturday or whenever I have some time free. And if you don't catch me then, I'll be back here at 9 p.m. Central European time next Monday. So in a week, that is, hopefully. Thank you very much, and enjoy. Bye bye.